Okay, sir. Can we start formally?
Yes.
Yes. Welcome to all. Welcome to your Space Club webinar series. Our 13th session is going on now. And first of all, we wish you, your Space Club wish you a happy Independence Day. And our 74th Independence Day is celebrating today. Not much of celebration due to COVID conditions. And more than that, we have to say that today, August 15, is the birthday of ISRO. In 1969, August 15, ISRO formed, and that's a good news for we are conducting a webinar in ISRO's birthday, and we are very happy to conduct this webinar, 13th session. And I would like to tell you that today we have a expert in space technology, introduction to space technology, and Shail sir will introduce him in detail, but I just want to welcome him. Welcome to Dr. N. Sundararajan sir. Welcome to the webinar, and our panel members, Sri PJ Bhatt sir, one of our great, one of the eminent scientists of ISRO, and welcome Bhatt sir to this webinar. And there is no need to specially welcome Abhinand, but it's my formal duty to welcome him. So welcome Abhinand to this webinar. And I just want to say that we will conduct a quiz competition. In last webinar, we just forgot to tell that in first part of this webinar. So all of you should remember that there will be a quiz competition after this webinar. We will post the link in the chat window, and you can access it only after the webinar has ended. And we just wanna, there will be a cash prize for this quiz competition, and it is sponsored by Cinder by Nature. And please attend the quiz competition. The result will announce on Sunday morning at 10 a.m. And also, I just want to welcome all other eminent scientists present here, our UL Space Club webinar family members, and our chief patron, our guide, our guru Kuttu sir. Welcome sir, and also Shajit sir. And no need to welcome this guys as it's only official. That's a formality. Only that is it. And I just want to request all of you, all of the participants, that please switch off your mic and don't and it will be an interruption to our webinar. So don't switch on your camera or mic, and don't present your screen in between. The speaker is going presenting the screen. So please be care of that. Careful. And one more thing I just want to say is, I just forgot that there is one more thing that the question answer session. Yes, one more thing. The question answer session. You can post the questions in the chat window. So we will collect the question and we will ask that after the presentation of our speaker. And I welcome Shajil sir to introduce our guests detail. Welcome, Shajil sir.
Okay, thank you, Varun. Today we have the birthday of our nation and the birthday of our ISRO. And because the ISRO is the background of this program, all these are the ISRO veterans who are controlling these things. And I make again a warm welcome to this program. And in this today we are so happy to be here because we had a technocrat in India who became a philosopher, and later he became president of India. That's our APJ Abdul Kalam sir. Today we have a technocrat who turned to become an academician and who become part of and building the future world, not India. He worked abroad also. And that was his duty. And when we consider in the maximum hierarchy of life, he reached in the form of a rishi or a master for these technologies. Now we are proudly presenting Dr. N. Sundararajan sir from Bangalore. And we can say he started his academics in the University of Madras by getting first class in honors in BE Electrical Engineering in 1966. and took his MTech from Indian Institute of Technology, IIT Madras, the most premier institute of India in 1968 itself, and electrical engineering from University of Illinois also. And he completed his educational pathway in India, in the Institute, and abroad also. And from 19 I was working in space a senior research associate NASA Langley in 1981 to 86. From February 1991, he was working in the School of Electrical and Electronic Engineering, Nanyang University, Technological University, Singapore. This shows that he completed his technical work profession from ISRO in 2000 and joined in the technological university to select his passion, the passion of his academician. And during his period, he was a visiting member to the leading institutional organization in India and giving lectures how to do good research. That's the way. He is also a research mind. He wanted to nurture research in India. And he was so passionate in giving these lectures in famous institutes in NTU, Singapore. And he was also part of our IAST. He was a Professor I.G. Sharma Memorial ARDB professor. I think it's an honor in the School of Computer Science and Automation, Indian Institute of Science, Bangalore. His research interests are in the areas of aerospace control, neural networks, machine learning, and published more than 250 papers, as also 6 books in the area of neural networks. And he was a fellow of IEE, an associate fellow of AIAA, and also a fellow of Indian Institute of Engineering, Singapore. He was an associate editor for IEE Trans on Control System Technology, IFAC Journal on Control Engineering Practice, and IEE Robotics and Automation Machines for Control Theory and Advanced Technology, Japan. He is also a member of Board of Governors for the IEE Control Systems Society, and he contributed major things to the India and to the world also. He was part of many manifolds of these technologies in the field of space. And one more thing that we can say, he's a good teacher and a good master. We can say today the students are so lucky to know the primary things to the high altitude of this space technology. It's not an introduction, it's an elaborate lecture. I could see some of his slides when we have conducted the trial run, and it will be a very interesting thing. And he don't want to make a lecture. He declared that he want to make an interaction. That's my request to the students. Whenever he asked, the chief guest asked the questions, you can unmute your mic and express your ideas. That is permitted in this session. It is done by Dr. Sundararajan sir is permitted us. And we make a warm welcome to our group, Dr. Sundararajan sir, to this UL Space Club that is under the control of Uralangal Labor Contract Society and Wagbada and the Edu project. We are making a good environment for our students to learn and explore and get blessed by these veteran and great scientists of India and of the world. So we happily welcome you to this forum, sir. We know you are always with us for the past few webinars. You are watching our activities, and that's happy that you are part of us. Thank you, sir. And today we have 2 panelists in this webinar, and we are happy to say that both of the panelists are our family members. PJ Bhatt sir is our guru. He is there with the UL Space Club from the year of 2016. And he is part of that. He is nurturing our students, and he is a guru for us. He's a master for us. And he was a group director in Satellite Control Center, Bangalore. And now he is nurturing a lot of children all over India. And he is also controlling a good group called Bahya Gasha and supporting all the students all over India. And I think he's enjoying that. That's why he is with us today. A warm welcome to our Guru, PJ Bhatt sir, to our forum. Next, our star, that is the Abhinand PS. Abhinand PS is part of VEP. He is selected from PEP. And our Kutti sir made a new way to him and he walked through it. Now he's in the way of his journey to the high realm. And whatever he wish, he will be like that and will be a good contributor to our nation and to the world. And I invite the only winner of Mias Maya scholarship from National Institute of Advanced Studies, Bangalore, to this forum, my brother and my student also, dear Abhinand, a warm welcome to this forum. And I invite all the veteran scientists from ISRO and who are taking part and sitting in their rooms in all over India to this forum again. They are part of the UL webinar family. I invite all of you with respect to this forum, sir. And I invite all the students and the parents also, and the common people also they are eagerly waiting, sir, here to know more about the space technology. Definitely, it would be a good lecture series. It would be a good thing for all the students gathered here. A warm welcome to all. And I invite our chief guest, Dr. N. Sundararajan, sir, to this forum for his marvelous talk. Welcome, sir.
Okay, thank you. First of all, I wish to thank UL Space Club, Kutti sir, Varun, and Shaji, all people associated with the club for inviting me here. Normally, I interact with students, so I feel very happy to be here. And as Shaji sir said that normally you do the lecture and have questions in the end, right? But I don't want to do it. I want to interact. And too much interaction also will be a problem because time is not there. Ideally, I would love that. But occasionally, I will stop and ask questions. One of you or two of you can answer. And the full question and answer we will take in the end. Of course, you can send the questions by chat. And they will work with me and near the end. And if your system allows that to unmute and then ask questions and get the answers, that will be great. Because this is not a, what you call monologue. I'm here to interact with you. You have heard a lot of space terms, but you really don't know what it is. That's the thing, you know. I want to quote, make a quotation here, Einstein. If you can't explain something in simpler terms, you have not understood that. That is his statement. Whether it can be a process, it can be a phenomena, it can be a product, whatever it is, if you can't explain that in simple terms, you have not understood it. We hear all these terms in space, right? And when you ask a question, not to students, even adults, when you ask a question, they can't really explain what it is. So my idea is to make that clear, some basic things, and overall I'll give an appreciation. And since I worked in SLB, I want to talk a little bit about SLB in the end. And my basic area of work was in launch vehicle, but we don't have much time on that. So that's what I told them, Kutti also, that we will do some other time to get into the details of that. Overall, I'll give the space part, and then we will have an interaction. You can raise any questions and start with that. Okay, so that is my background. And if the time is running out and you are running into problem, please let me know, because the professors are notorious for not stopping lectures unless the bell rings.
Okay, sir. Okay, sir.
Yeah, so I will go on do that. Now let me start my presentation. Just hold on for a minute. I go with my entire screen. Okay, that is it. Share. Then I go down. You can tell me, give me a feedback whether it is coming all right.
It's coming. Not. The presentation is coming. Yeah. We are seeing your slide, sir. It's okay.
Okay. Yeah.
Okay, sir.
So I will hide this.
Okay.
Okay, I have to go here. Full screen?
Yes,
okay.
Full screen. blank.
Yeah.
Now we get a blank screen.
Yeah.
Yes.
So
Okay.
I'm going to give an introduction to space technology. It's a huge subject, and space technology covers all areas. So what I will do is try to cover some basic aspects, and that's why I want to say introduction. Normally this title is overview, but overview is very big, so we will wait for that. And incidentally, my name is Sundararajan. I worked 20 years in ISRO. My first job was ISRO, joined in 72 VSSC. Basically, I am from Tamil Nadu, Tanjore, but I settled in Trivandrum and worked for 20 years, so I know Malayalam. So you can talk to me in Malayalam also, I will answer. But that will be Trivandrum Malayalam. Tamil and Malayalam together it will come. So then after 91, I left to Singapore. I became an academic because I wanted to, my passion was teaching. Again, it came from a long time, teaching and research. So I was in Singapore till 2010 and I retired. Nowadays, I go around all the institutions, universities and all, talking to people on how to do research, but space is my pet topic. Normally, we did this talk in school children, the final year school children, to make them to come to engineering. That was the motivation there in Singapore, because all the fellows were going to business, commerce, and all that. So not many people were coming to science and engineering. So to motivate them, space technology is a fantastic. You are already there, US Case Club. I don't have to motivate you, but you take this message and motivate your other classmates and other people who are more interested in business, money making, and all that thing, right? So science and space technology is still very interesting. Okay, so that is the main motivation. And of course, my email is there. It's just I'll give you the thing. You don't have to note down. My name is truncated, N Sundara, and E is for electrical engineer. The coding is done like that, En Sundara, gmail.com. That's it. Okay. So then, first of all, I had to wish you all happy Independence Day, because this is the 74th Independence Day. If I don't do that, I will fail in my duty. And incidentally, I wanted to tell, Varun already told, today is also the birth date of ISRO. ISRO was born on 15th August 1969. And you can see that when they started, there was nothing. It started in a church in Delhi, and it has built, and space technology has pervaded everywhere. And space technology is one area. If you are advanced in space technology, you are advanced in all the disciplines. That is what we are seeing. Any area of science and engineering, we are seeing that. So we are in the right direction. And the motivation my talk is everything you wanted to know about space, because you read a lot of things in newspaper, right? I'll give you an example. You read that they put a satellite for weather monitoring and taking imaging and all in sun synchronous orbit. My first question is, what is a sun synchronous orbit? Don't tell me it is synchronous with sun. See, this is what happens. I go home for vacation. My father is an agriculturist. He is not in this area. He asked me, "Arey Baba, what are you doing?" "I am working on space technology. I am doing orbit design and all." And he suddenly asked me, I read this in the newspaper. They say it is 800 kilometers unsynchronous orbit. What is a unsynchronous orbit? So most of the time we don't know the answer. The best way to avoid the answer or evade the answer is, "Hey Baba, Pa, you don't have any other time. I have very busy. I have to go." You run away from that. Okay? So that is the aim. But if you talk about something, you should know. Say, develop that habit as a student. That will help you a lot. I mean, first time nobody will know, but slowly you have to find out. And you are afraid to ask because people think you are a fool. No, never. In a class for learning, again, there is a quote. During a learning or class in a lecture and all, if you don't ask a question, you are a fool only up to that time. If you never ask a question, you are a fool throughout your entire life. So don't feel shy or silly when you ask a question. No, you want to know, right? So that is the best thing. So that is why I always ask my students to interact and ask questions. Don't worry whether it is silly or wrong. Okay. So that is the motivation for this talk. First of all, I worked with Kavan for 20 years. I know him well. And he was my first boss and mentor and a friend and all. And when we started this, I will talk about this in the end. When we started, nothing was there. We were all like you, your Space Club members. We are very raw from the school. Whatever we had done is only in the books. And even that subject, most of the time you forget. So from that, you got some 15 fellows and 200 fellows to work on a project and develop and all. Fantastic achievement. And we know at that time, I didn't know at that time he became a president, but I know he was a very sincere and hardworking person. He will go places, but he really went to the president of India. And later also, after retirement also, he's so no introduction to that. That is the first one. He was. Second one, very recently, I was very sorry to hear that, very sad also. On August 10th, Dr. Gupta passed away in Trivandrum. I joined ISRO under him for the control system division. At that time, it was called Control Guidance Instrumentation Division. And all the control guidance of ISRO's launch vehicles, even for a lot of systems for satellites, everything was developed in that group. And he was my first boss. And he is a person, very simple person, technical person. You can argue with him on technical points. He had the maturity to accept it, even if it comes from your subordinates and other people. He really contributed to the guidance and control systems in space. And he is a very quiet person. But very recently I heard that he was sick for some time. That's what I heard, and passed away in this thing. So I want to dedicate this to him also. Okay. Introduction. Now I'm going to come to the topic. Hope you can listen, right? Is it okay?
Yes, okay, it's okay. It's okay.
Yeah, you give me some feedback because I'm not able to see you because I'm full screen view slide. Occasionally, I'll ask you a question. One of you can respond, the controllers. Yeah.
Hello.
Yeah.
Sir, can I answer the question?
Which question?
The first question you asked.
What is the question? I didn't ask any question.
About the synchronous orbit, sun synchronous orbit.
No. I have not come to that. Hello, wait. Who is this? Varun, is it?
No, sir,
No.
it's Adidev. Varun is here. Varun Vadagara. That's ID.
No. Who is the person who asked? Because the other people don't know.
Adidev JD. Adidev.
Yeah, you wait. If the question comes, you answer. Okay. I will ask questions. No problem. Okay. The outline of the talk is, first I'm going to talk about history. Because you are all Space Club members. You are very eager to know about space and all, you should know history. Very, very important. Okay. Then the second is, without knowing basic orbital dynamics, you don't know space at all. Okay. I want to ask a question here now. There is a subject in your maybe high school last year or in the PUC or something, mathematical subject, which you never use when you go for a job. Can you name that subject?
Calculus.
You don't really practice it. Yeah. Which one?
Calculus.
No, calculus you use all the time. Any other answer?
Statistics.
No. Hello. Statistics is a whole now. Data analytics.
Number theory.
No. Number theory. Maybe coding. You are using. There is one.
Trigonometry.
No. Don't tell me all the things. I will say no. Think and answer. There is one subject in high school at the SLC level or PUC level in mathematics you study, which you never use later. Okay, what are the subjects you study? You tell me, I'll tell you. Algebra?
Geometry.
Huh? Geometry you still use, madam. You use in beginning. Not abstract maths. Ella tappu.
Set.
Huh?
Set theory.
Question manasalayo.
Yes.
Okay.
Sir, there is no such subject.
Completely wrong.
Sir, matrices.
Matrices எல்லாம் use உண்டு madam. Okay, I'll give the answer.
Complex number.
The time is not there. I'll give the answer. The subject
Complex
is
number.
analytic geometry. Do you know what is analytic geometry?
It's a combination of algebra and geometry.
No. Don't say. What does it talk about? Analytic geometry.
I don't know.
You have not studied this analytic geometry?
Yes, sir.
Equation of a curve, right? Equation of a straight line, equation of a parabola, equation of a circle, equation of a ellipse. Yes or no? No?
Yes, sir. Yes.
Yes.
Yes, sir.
Okay. If you want to come to space, you should know that. That is the point. Orbital dynamics, nothing but analytic geometry. So if you are planning to, that's what I tell all the students, what is the way I should prepare to join ISRO? Do I have to read and study space and all? No. Your fundamental maths and physics should be strong. That's enough. You will learn on the job. So analytic geometry, if you are because everything in orbital dynamics, everything is based on analytic geometry. I'm going to show you that. Okay. Then I will talk a little about satellites. By the time will be over, so I want to say something about SLV3 where I worked, and then we will close it. And the launch vehicle technology we will take separately in future some other time. We don't have time, and we will do the question and answer. This is what I am going to plan. Okay. First is history. The first question. See, space has been there for a long time, right? 100 years, 1,000 years, and all that. Our people, mankind, got interested in space by an event which happened. Can you name that event? What was the first event? People got enamored in the earth about the existence of space and wanted to do something. One event changed. Maybe students are not born at that time, but adults would have been definitely. Can you name the event that shook up the entire world and started looking at space and thinking?
Supernova or comet or stars?
No, wrong. That is there for the entire lifetime.
Discovery
One-
of
Huh?
invention of telescope.
No.
Sir,
For
comets.
space. Huh?
Comets.
Comets already exist. See, now I'm telling you, you are all school children, right?
Sputnik.
Tell me one-
Sputnik.
Sir, Sputnik.
Correct answer. Who is that person? Can you identify yourself?
Sputnik.
No, your name.
Sputnik.
You identify yourself. Hello?
Please
Give
tell your
and
name.
school. Yeah. നിങ്ങളുടെ സ്കൂൾ പറയണം.
GHS Spoonur.
Okay.
Name
Sputnik.
also.
What is
Fatima Hiba.
Yeah, that's okay. What is Sputnik? Give me some explanation. What is that?
Sir, can I?
Yeah, try.
Sputnik is the first artificial satellite
Launched by?
Yes, sir.
by USSR.
Okay. Which year?
1954.
Birbal would answer. Birbal number. Okay. What is the correct answer?
1957.
For the
57.
Correct. Okay. Kolam. Okay. Correct answer. Very good. Okay. This is the point I want to make. First satellite launch, a man-made object was put into orbit around Earth. That caught the attention of the entire world. Russia did it in 1957. And I was a schoolboy like you. And the great thing is, why it got attracted is, I used to have a radio. I can tune to that frequency. And Sputnik was sending signals, beep, beep, beep. I can hear it. When it passes over my town for 5 minutes, I can hear. That was the trigger. Okay. The first satellite launch, you can see this here. This is a satellite. October 4, 1957. First satellite Sputnik, its mass was 84. It transmitted, it was there for only 21 days. But this is the one, it caught the attention of the entire humankind. They said, oh, something man-made is going around and doing all that. And that was the thing. But space has been there for a long time. So a man can put a satellite into orbit. That was the first one. Okay. But the satellite was 84 kg, but see the rocket. So that means it's so enormous. You need so much energy to put a satellite like that. Of course, this was done by Russia. And at that time, there was a big Cold War between Russia and US, right? America. If Russia does something, America will do immediately. Correct? So immediately, what is the next one happen? American launch. What was that called? It's called the Explorer. Okay? 58. Successful satellite launch. Its mass was only 5 kg. Whereas the other one was 80 because they had the power. The rocket was enormous, but American launch satellite was very small, but it did a great discovery. It found Van Allen radiation belt. First time. So that means there are a lot of area around this Earth's atmosphere around that, which are charged particles, and if you send a signal through that, it will be completely lost. Existence of radiation belt was discovered. Okay, this is the first important. Okay, this is what I'm saying, and this is what they mapped it actually. Radiation belt. You can see that area which is marked with the dots. That area is the. So that was the. Even though the satellite was very small, the discovery was great. Okay, now I had to go further. Okay. Can you tell me, okay, first Russia launches satellite, America also launches satellite. What will happen next? Russia has to do something, right? What will you do?
Tells human to
Human. But can you send a human satellite? Hello. You
no
tell me.
animals.
No. You send a satellite. It has
Sir,
gone.
animals.
What animal first they sent?
They gone for like
Dog.
A dog.
Wherein launched
Dog.
on
What is the name of the
the
dog?
worst of
The dog named
Laika.
Laika.
Like
Right. Okay. Russia launched a dog. And then after that, what is the thing? You have to put a human on space, right? Before that human, you have to send something else. What is that? First is a satellite, Sputnik, then a dog, then before the human. Who is the human?
A monkey.
Monkey. Correct. Primate. Correct. Because monkey is close to humans, right? Yeah, monkey was sent. And then the human. Who is the first human in space?
Yuri Gagarin.
Yuri Gagarin. Okay, everybody knows that. And when you send a man, what is the next one?
Alan Shepard.
No, that's okay, man. But what is the next step?
A spacewalk.
No. See, if you send a man, how can you leave a woman?
Yes.
Who is the woman? Who is the woman? Valentina Tereshkova.
Valentina Tereshkova.
See, that is how it is built. See, because of all those capability, we are going with Gaganyaan now. See, they did with a dog, they did with a monkey, they did with a man to get into, just to go around space. And then women, all that. Then what is it? They said, what is the major event after that?
Spacewalk.
No. Walk is okay, but major event. Land on the moon. That's what they did. They sent a person, Armstrong, 1969, went into moon, landed, and came back alive. That's another great thing. These are all really adventures. Okay. Now you get the idea. You should know, if you are working in space, you should know this history. You don't have to remember the dates and all. That's okay. But roughly the first one you should know. The 69 you should know. Then you see a shuttle launch, satellite repair by shuttle. Then they brought the satellites back to Earth. All this technology is in steps. That's what is a Armstrong statement, right? The first step, what is that? He said, first step for mankind. something like that. So this is okay. Okay. Now, even before that, let me go further. I'm going to still older time, solar system. Anybody can say anything here?
Sir, Earth was at the center.
Who said that?
Adidev JD.
Who?
And Ptolemy.
Okay. Let me see. Let me go and do it here. First, Aristotle said, theory of heavens being made in spheres. Copernicus, sun is the center, planets move around. Tycho Brahe, you may not have heard him. He did the orbit measurements. Remember, there is no computer, no internet, nothing. Instrumentation was very poor. Electronics was not there. Visual observation, he made precise measurement. Mind is the thing, not the instruments. Kepler, without Kepler, we would not be in orbit. Okay, and Galileo. And finally, who?
Newton.
Newton, of course. Newton, gravity, orbital velocity, escape velocity, all that came out. Okay. Now I'm very briefly I'm touching. It's again a quiz. I put a figure. Can you tell me who this fellow is?
Copernicus.
Okay. Okay. Let's see. Is it correct? Correct.
Yes.
Yeah. Sun is correct. Okay. Who is this? Terila.
Tycho Brahe.
Galileo.
Huh?
Tycho Brahe. Tycho Brahe.
Correct. Very correct. Very correct. You see the years also. How it developed. 1473, 1546. And this one?
Galileo.
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 Yeah. Observation of distant stars, planet Jupiter. You see the years, how the jumping has happened. Technology, I mean, not technology, knowledge wise. Okay. And the next one is, who is this?
Kepler.
Kepler.
Yeah, Kepler. And this is, of course,
Isaac Newton.
Isaac Newton.
okay. These are all the people. So what is a Kepler's law? It's just that orbits are ellipse. That's what I said, analytic geometry. What is the equation of the ellipse?
X square by S square, Y square by V square is
Is equal to 1.
Yes.
Okay, what is the equation of what do you call parabola?
X square base BX plus C square.
No, the normal way we teach maths. Parabola.
Y square equals 4x. Y square equals 4x.
What is the equation of a rectangular hyperbola? What is the equation of a straight line?
AX
Y equal to MX.
Y is equal to mx plus c. What is the equation of a circle?
X square plus Y square is equal to R square.
Correct. Circular orbit means that's it. Ellipse. Now you see eccentricity and all these things are coming. So, okay. So this is a very important law. Second law is this. What is that? Equal areas and equal interval of time. Okay. What is that thing? Angular momentum is conservation of angular momentum. If you want to work in space, you should know this. You can't forget. Please say, but can confirm this later. Because we did all this when we were working on orbital determination. Okay, this is the very important law. This is called the 3/2 law. Period is inversely proportional to 3/2 power. Okay, so of course then the law of gravity, correct? And you see the velocity. First of all, if you work in space, you should know this. Radius of Earth is 6378 kilometers. So you should know G, you know the mass, you can calculate, and the escape velocity is around 11 kilometers per second. In 1 second, 11 kilometers. So much energy you need. Okay, so that is the point. Now you get, how do you get the satellites into orbit? So if you throw it, that is the picture. If you throw it, if you give correct velocity, if you don't give a velocity, it will go up and then come down. If you still increase the velocity, still it is not enough to escape. But if you give the right velocity, it will go around. So essentially, giving the right velocity based on Newton's law, you can get into orbit. Now, this is what I have. Okay, let me go back here and close that and show that. There is an animation here. You can see how we get into orbit. Can you see it? Hello?
Yes, sir.
Okay,
Yeah,
sir. It's
okay.
okay. It's okay.
Yes, sir.
Now you see here, V2 is greater than V1. If V3 is greater than V2, then it gets into orbit. Now, if the velocity is not enough, it comes back. The range is small. What do you call this? Can anybody tell me? Okay, I stop here. Hold on. What do you call this? See,
Projectile
if you
motion.
give the right velocity, you go into orbit.
Trajectory.
No. Trajectory is okay. What is the system here? See, you try to
Projectile motion.
Huh? No.
Projectile.
No. I'm not asking the trajectory. I'm asking.
Orbital velocity.
No. Nothing to do velocity. I'm saying, see, if it gets into orbit, it's a satellite, right? If it doesn't get into orbit,
It's a projectile motion.
yeah, but what is it called? What is that system? Okay, I'll give the answer. See, do you agree this range is smaller than this range? Second one is a more higher range. What is this? This is nothing but intermediate range ballistic missile. A launch vehicle, if it gives a right velocity, it becomes a satellite. If it doesn't, it goes up and comes back. Depending on the energy, the range can be smaller or larger. This is IRBM technology. This is ICBM technology. That's it. So that is why they say space technology is dual use. If it goes up into orbit, it is space. If it comes back, it is missile. That is the point. Okay. So, of course, we want to get into orbit. We don't want to do this, but it can be used. And that has happened also. Okay. So, let's continue further. Okay. The next one is, this is how the satellites orbit. Gravity is pulling the centrifugal force. There is an equilibrium and satellite goes around the orbit. Okay. Now, you can calculate for different altitudes the velocities. What is the orbital velocity and orbital period? You see here 1, 2, 3, 200 kilometers circular. Orbital velocity is 7.77 and period is 1 hour 28, around 90 minutes. You can see here. Now you go to point number 4, 36,000, which is around 24 hours. So the period for orbital period is the same as Earth rotation. Those orbits is the geosynchronous orbits. And if it is in the equatorial plane, it becomes geostationary. So this was all done with Newton. Okay. So now how do you define space thing? First of all, you had to, I'm giving an overall picture, very crude, but it's okay. You had to, what we call as how do I start a space project? First, you have to define the mission. What is the mission? Mission means what is your objective? Mainly the mission is coming from applications. What you want to do with the satellite, okay? PJ Bhatt was very much involved in this. I was also involved. I was involved from the rocket side, launch vehicle side. He was involved from the satellite side. Mission division, their division is called MOPD at that time. Mission Operation Planning Division. Mission definitions, you define the applications first. So it can be communication, or it can be remote sensing, or it can be navigation, which are common, and it can be science. Some scientific experiments can be there. So you have to design that. What do you want to do with the satellite? Once that is defined, then you have to define this orbit. What orbit? What is the payload? How much weight? So this is coming in step by step, and immediately specifications. If you put a camera in a payload and you want to point and want to take an image, the pointing should be within certain arc second. All this will define the specifications. So these are the things we have to meet and design. A satellite for this, a rocket to deliver to satellite to that orbit with that specifications. Very, very complicated one. Okay, once it is done, then they go and design the satellite. How much power, how much payload, what is the structure, everything is designed. So satellite design doesn't go alone. Satellite is an on-orbit point. There is a ground equivalent segment for that. So the tracking network, right? You can launch a satellite, but you have to track it over its lifetime. So they go together. This is like husband and wife. They always go together. Maybe not initially. Initially, the fellow is a bachelor. They can do that. But somewhere else, the marriage has to happen. And then this has to go to the top and the mission is achieved. Once you do this satellite and all, then comes the rocket. Right? What is the rocket? What specifications it has to develop and deliver? And again, when you talk about rocket or launch vehicle, the pad also important. Where do you launch? The launch pad location will determine the size of the rocket. Okay, very, very important. So everything goes together. And if you do all this and do this successfully, then the mission is successful. That's what recent PSLV launch, GSLV launch, you would have seen in TV. There is a mission director, there is a satellite director, there is a launch vehicle director, there is a tracking network director, there is a launch pad director. All the directors are sitting in the mission control center, and finally chairman of ISRO comes and says the mission is successful. Means so much effort and so many period of time, and everything has to work without any failure in precision. To achieve this is impossible. We have done it. Of course, again, Kalam's point, our first attempts are all failures. You learn more from the failure than from success. You learn from the failure and correct it. And once you correct it, you understood the system, the failure is very, very remote. That's what we are in stage. Okay. Now, I want to say, any questions at this point? Is it taking time? Can I go? Hello?
Yes, sir. Yes, sir.
Yeah, I proceed. We will ask the
Okay,
questions
sir.
in the end. Yeah. So, introduction to orbits. Now I am going to that part. Right? I said that with the right velocity, that's why the term VC is used. VC means circular velocity. If I give the right velocity, the shape circle, x square plus y square is equal to r square. Very, very important. If I give more velocity, what happens? Circle becomes ellipse. That is why when you study analytic geometry, you don't say circle, ellipse and all. You call equation of a conic. If you cut a cone at different angles, you get different shapes. Conic section. Okay. If you give more velocity, it becomes still ellipse, but the eccentricity is higher. Correct? Highly elliptical orbit. That means then it becomes a parabola, more velocity, and then finally you get rectangular hyperbola. You can see that if a rocket can deliver a velocity, circular velocity, if it can deliver more, you get parabolic orbits and hyperbolic orbits. Why do we need? What is the difference between the circular orbit and parabolic orbit? Anybody can say that? I want some answers here. Either circle or ellipse. What is, by looking at the shape, what is the difference between this? Please try.
Difference in the eccentricity.
No. Between ellipse,
The radius changes. Radius changes.
Huh?
Radius changes. Radius of the orbit.
Hello. Let me show this. See, you take all this one family, you take this other family. And say, what is the difference between
half of the circle?
Bounded and unbounded orbit.
You see, circle is a special case of ellipse. Okay. So when I say ellipse and parabola, what is the difference? Simple question.
One is bounded.
Length of radius.
Correct. You said bounded, right? I will say the other way. One is closed, another is open. Correct? When you say the orbit is closed means you will go round and round. When it is open, you go out. Now, where do you use parabolic or hyperbolic orbits? Anybody can tell?
Interplanetary missions.
Very good. For interplanetary mission. Yeah, very good. Correct. You see, you don't need a circle, right? You don't need a closed curve. You have to go. And if you want to reach in a shorter time, you go with hyperbolic orbits. That is why I said analytic geometry is the fundamental operating principle in orbit dynamics. So this is what they do. So everything is useful. Okay. Now you see here, you know the perigee and apogee, right? Perigee is the lowest height from here. Apogee is the highest point in your orbit. You call it G. Why G? Actually, the point is peri and apo, but we call it G. Perigee, apogee. Why? Why?
G means Earth.
Means what?
Earth.
G means Earth.
G. How does it mean Earth? G means
Geo.
Geo. Correct. What is geo? Language?
Latin.
Hello. The name of Earth is geo in which language?
Latin.
No.
Greek, sir.
Greek.
Greek.
Greek term is geo. Perigee, apogee. Okay. If the satellite goes around sun, what do you call it? Peripoint. You don't call perigee for your sun, right? Huh?
Perihelion and
Apohelion. Okay. If it goes around moon, what is the Greek name for moon?
Selene, I guess.
Selene. Correct. Okay. Periselene and
Aposelene.
okay. I will throw one more Google. What is if you go around Mars, what do you call it?
Peri something.
What is the Greek name for Mars in?
It was Aries or something. I think.
Aries. Correct.
Aries and.
Correct. That's correct. Okay.
Thank you, sir.
So this is the meaning. That's how they named the thing because of the Greek earlier time. Perihelion, preselenium, aposelenium, perigee, and apogee. How it operates, you can see here. Animation. At the apogee, the speed will be smaller, but when it comes to perigee, the speed will be higher. Can you explain why it happens like that? Why the velocity at apogee is smaller and velocity at perigee is higher?
In equal intervals, equal area must be covered now.
No, that is okay. But what is the basic principle?
What is
Conservation of angular momentum.
Angular momentum. I will say it's conservation of energy. What is the energy? Energy consists of
Gravitational pull.
No. Generally, energy consists of energy. What are the types of energy you have?
Kinetic and potential energy.
Potential energy. Now you explain.
What's that?
Kinetic energy is
When potential
energy possessed by the virtue of the motion of the body is kinetic energy.
Yeah.
And by virtue of the position and configuration of the body is potential.
Blah blah blah. Hello. Blah blah blah. Don't give all that. Kinetic energy, I will explain. Kinetic energy of mv square. Potential energy mgh. Correct. So if your height is small, velocity is higher. If your height is large, velocity is lower. Conservation of energy. Now you know, right? Okay. Is it? Sorry. Very bad. I think I'm going somewhere else. Chat. Hold on for a minute. I jumped. Okay. That is why this figure, you see that at the apogee, the velocity will be smaller. It will go smaller. And of course, equal area, equal time, and all that thing will come. Essentially, balancing of the energy is happening. Okay. So This is very important point. Okay, so this is how it is. Okay, let's go further. Now I want to talk about satellites a little bit. You got the basic. I didn't go more into orbits. I can go. What is the shape of orbits? What is the orbital plane? All that. You don't have time. We can do that separately if you want. These are the different orbits. Okay, let me ask you some questions here. The figure. What is the name for this orbit? Okay, this one.
Geostationary orbit.
Geostationary. And this one?
Sun-synchronous orbit, also known as polar orbit.
No. Not all polar orbits are sun-synchronous. Don't say that. It's just a polar orbit. Okay, correct. Then this one? Where is this? This one?
Low Earth orbit.
Low Earth orbit. This one? This one?
Geosynchronous orbit.
No. Geosynchronous. Okay, correct. But more. Okay. Shape.
Inclined orbit.
Inclined orbit, but shape. How is the orbit shape defined? What is the name?
Elliptical orbit.
Elliptical, highly elliptical orbit. Inclined. Okay. Now you see here, inclination is 0, equatorial. Normal inclination is this 40 degrees. Polar is 90 degrees. Right? And altitude, LU low Earth, geosynchronous orbit, ICO, intermediate circular orbit or intermediate elliptical orbit, ICO. Okay? Then is orbits defined by the shape. It can be circular, elliptic, closed curve. Parabolic, hyperbolic, normally we use for planetary travel or moon travel. You want to go across planets, you can't be in circular, elliptic, and I say I'll go to moon. Wrong. It has to be parabolic, hyperbolic. Hyperbolic, more energy, you will reach faster. That is the point. And why all these options are available? Because of the application. What do you want to do with the satellite? Okay. Remote sensing. Okay. Normally, remote sensing, which orbit is preferred?
Low Earth orbit.
No, that's okay. Low Earth. Which one is preferred? I have given you all the options. You have to design a remote sensing satellite. Which orbit? Polar orbit. Yeah, correct.
Unsynchronous polar orbit.
Okay, right. We will come to that. Communication.
Geostationary.
Okay, navigation.
Geosynchronous.
Hey. It's okay, but
Polar orbit.
No. Navigation is not polar. I mean, you can do, but low Earth orbit is fine. Low Earth orbit is fine. Surveillance.
Navigation is geosynchronous.
Okay, so this is how they decide. The application is the one which is driving. Then you select the altitude. Then you, depending on your launch pad, again that will come into inclination, and finally you select the shape. This is what we call geostationary orbit. What is the difference between geostationary and geosynchronous? On the day I asked. Somebody wanted to answer?
Geostationary orbit because it faces only one side of the Earth where it was originally placed.
Don't give me all the story. Simple difference between geostationary and geosynchronous.
Okay, sir.
Geostationary orbit
have any variation, but
Hello, one person, please. Yeah. Go ahead.
Okay, sir. So geostationary and geosynchronous orbits both have an orbital period of 24 hours. But the geostationary orbit is a circular orbit above the equator. The other is more of an inclined orbit, so it doesn't stay on the same spot above the Earth. Whereas on the geostationary orbit, it looks like
very correct.
Directly
why do we need geosynchronous orbit? Why people use that? Yeah.
Pardon me, sir.
Why people use geosynchronous orbit then? See, ideally you want to put in geostationary, right? That's the ideal thing.
Yes, sir.
But then why people are using geosynchronous orbit also?
Navigation.
No, not navigation.
Sir,
Okay.
because there are places which is beyond.
places such as Russia, America, North America.
Yeah, right. Why? Maybe I should not talk about that now because that's a quiz question, right? Is there quiz question? Yeah. Correct. I will leave it. You find the answer later. Otherwise, I will explain later. Geostationary is a special class of geosynchronous orbit, which is equatorial, circular, and if you put a satellite on that point above, say, Bangalore, it will remain visible to Bangalore all the time because both the period is the same. Yeah. So ideally, this is ideal for communication. Okay. The next one. Okay. Orbit motion matches with that spin rate. Same. So you will be stationary. This is the polar orbits, right? Inclination. Now you define sun synchronous orbit. What is a sun synchronous orbit? Anybody can tell me? Why the name sun synchronous? What is it? See, geosynchronous we know, synchronous with respect to geo rotation rate. What is sun synchronous mean?
Sir, it will complete one revolution in a year.
No. Sun synchronous.
Sir, nearest
Complete one
polar orbit
revolution
of
in one day on the sun.
planet.
One day. Yella kolla.
Sir, can I explain? Can I explain?
Okay.
Can I explain?
Yeah, try.
The satellite will be above a particular place at a particular time.
Correct. All that right. Why is sun synchronous the term? What is it to do with sun? Okay, I'll give the answer. Yeah, this is what I said. The answer is this. If you see the thing, useful for communication and remote sensing over polar region and other region. Now I am going to put the figure. Can you see this figure? Inclination is more than 90 degrees. What? What do you observe from the figure? Hello? Can you see it? Okay. The answer is, this is the point. Orbit is constant angle with respect to sun. Sun satellite line, right, is always with a particular angle with respect to the orbital plane. Why? Because the season, I give you the reason for this. You take an image in winter, you take an image in autumn, and you want to estimate the crops. If the illumination is different at different times, your assessment of the crop development will be wrong. Illumination has to be same. When you take a photo, today you take, after 6 months you take, and you want to compare these two photos, the illumination condition should be the same. Then only you can see whether it grows or not. So sun synchronous orbits are very special in the sense the satellite orbital plane and the sun earth line is at the same angle during the entire season. This is a special case. All the other things, whatever you said, it will visit the same point, and that is how it is very useful to take the photograph. Every day morning 10 o'clock it comes over Calicut, it takes a photo. Every day or every 1 week you take a photo and see whether the paddy field has grown or not. All these experts are here. PJ Bhatt is there, Kuti sir is there, all these people, no? They work day and night, sun synchronous orbits. Of course, you can use it for other applications also. Okay, so those are the things which drive the technology. I told you, all kind of applications are possible. Okay, 3 areas: communication, remote sensing, navigation. Communication is geostationary. Remote sensing is normally polar orbits. Navigation is low Earth orbits. Normally, you can do with geosynchronous also. So I'm talking about GPS and all here. Okay, we will talk about that. What is remote sensing? Very quickly, let me go. You can do Earth observation. They are all expert. Kuti sir is the right person. He can give one talk only on this. Infrared, microwave, hyperspectral, multispectral, all kind of things have happened. Solar system, science. They are sending one satellite to solar, sun, right? Helios is coming. All the other things. And galactic observations. Okay, all these are possible. Black holes. He talked about why black holes are not black, right? You can find out whether they are black or white. Of course, atmospheric studies. I will go through this very quickly. So different altitudes, different spheres you can study. And remote sensing, this is just to show one volcano erupted and the plume was spotted. The details are given here. So even now, Indonesia and one airline got into problem, it went into the plume and the engine failed. Over Indonesia is a hotspot always. So they will route the airline trajectories around that so that to avoid this problem. This one example. This is the main point, imaging, right? How do you take imaging? See now, sorry. You can see here, this is a satellite, camera is here. So this is at 500 kilometers means the Earth. This is what we call as a swath. And that will be a frame like this, 75 kilometers, it will take a photo. But remember that it is moving, nothing is static. Satellite is moving, Earth is moving. So it comes over a particular point only for a short duration, 6 or 7 minutes. It has to take the photo. Then it has to send it to the ground for processing and analysis. So it is stored on the satellite, and when it comes over the station, next time it downloads that. Okay? IRS, SPOT, Landsat and all. This is how it is done. The next one I'm going to show is the animation of that. Okay? Watch me closely. Now you can see here. Sorry, I had to stop here. Okay. Earth is rotating, satellite is coming. Now you see here, this is what we call as the aperture of the satellite camera. It can take a photograph of all this. Now, what is the problem in that? Satellite is oscillating. Earth, the atmosphere is changing. So everything will make the image very blurred. This is why they need the complete remote sensing agency and centers are there to make all the correction and to get the data. And depending on the instrument accuracy, you can get within 2 meters accuracy in the ground. It looks simple, but to make it work, it has to take the photo, it has to store it in the onboard memory. When it comes over the station near shower or something, it has to download. Everything has to happen. Sorry. You get an idea? Earth is rotating, satellite is moving, and it comes over a particular area only for a short duration. And depending on the height and the camera, the clarity of the picture. And it is vibrating, oscillating with the atmospheric correction, ionospheric correction. All these corrections has to be done pre-processing. Generally, you can analyze. Okay, we have mastered the technology now. I can tell that. And Kuti sir can talk about this further later. Okay, this is another observation, weather observation. Nowadays, you see cyclone. You see a cyclone in Arabic Sea, which is very rare. Nobody has noticed. Now you say it is going to hit Bombay. How do you do that? All this is possible because of satellite observation, because they are watching you all the time. And they combine with the satellite image and they have a prediction model. And they say it will come and it is going to cross, but it changes. There are so much uncertainty, but it is being used for our benefit. Weather satellites. Most of the time you can use geostationary, but very expensive. Normally preferred is polar. You can see this image, and I'll show you animation of that also next time. You can see continuously we are monitored by weather satellites. Not only the weather, they also give the wind. So the airline can plan their intercontinental routes accordingly. So you are on 24 hours observation. You can predict volcanoes, hurricanes, cyclones, everything. And it is real time also. That's how Madras weather fellow Ramanan predicts, right? I don't know. Random somebody should predict also. It's coming out. So they have earlier we set up the thing, and now the data is feeding into all the local stations and give a disaster warning. How do they say Calicut is going to get a heavy rain in 3 days or 2 days, red alert and all? It's all possible because of this. Okay. Then communication. Correct? We start about geostationary orbit. Very important. The person invented this, Arthur Clarke. He's a great scientist, engineer, science fiction writer. Space Odyssey was his thing. He was settled in Sri Lanka, British scientist, settled in Sri Lanka and passed away recently. Even before the satellite and all, this is come. In his notebook, he has drawn the configuration. This is a plan view. See, he says the pole, right? You see here, he visualized this 22,000 miles, which is 36,000 kilometers. If you put a satellite at an equatorial circular orbit, it will be stationary with respect to the point above that, and you can use it for communication. See, mind is the very strong thing. At that time, the computer and all was not there. He is the main person for giving this idea. Of course, he didn't patent it. That is the problem. Okay. So he gave 3 laws. I want to highlight that. Okay. Very, very interesting. You see here, first one, when a distinguished but elderly scientist says, like me, something is possible, he is almost certainly right. When he says that something is not possible, impossible, he is probably wrong. Technology is going like that. Okay. He says something is possible, you can accept. If he says something, you can't do this and all, within 5 years, the whole thing will change. That's first statement. Second statement is very, very profound. I like it. This is what he says. The only way of discovering the limits of possible is to venture a little way past them into impossible. This is very true for any person. What you can do, what you cannot do. What is your limit of capability? If you want to find it for yourself, you have to go into something impossible. And if you fail in that, then you know what is your limit. Very profound. So, initially, just don't say that it is not possible. No. This is again the motto of Kalam. Dream things and try to achieve the dreams. Dreams may not be possible, may not be implementable, but at least you will know your capacity or capability. Okay. The third one, any advanced technology is magic. That's true. Correct? Your communication, navigation. Earlier we don't know where we are. Now, everywhere I get my position. So it will change in a drastic way. I find this is very, very useful. Yeah. Okay. So let's continue. This is what he said, that information transfer, internet, a lot of startup companies are working, satellite-based internet. Okay. And all the satellites are helping a lot in this. So this is a thing. I will not get into that. GPS. How does a GPS work? Okay. A lot of people, I ask this to a number of students. They say, in my mobile phone, I put it and it comes. Yeah, but how? Essentially, what you do is, I give the answer. Normally, I spend time on this, asking questions. Essentially, you get the range. How do you get a range? From your mobile phone, you send a signal to the satellite and it comes back, a response. You take the time taken for going up and coming down, and using velocity of light, you calculate the time and the range. So the timing is very important. Then if I get one satellite range, is it enough? No. Civil engineering surveying tells you need 3 ranges. So you need 3 satellites. Okay, I get 3 satellites, 3 ranges. And the thing is, the satellite positions are exactly known. Then my surveying says, this is what we call surveying wise, triangulation. I do the calculation based on the satellite positions. I can fix my position. Of course, this is all done in geographic coordinate system. That's why you get latitude and longitude. And in 3-dimensional, you will get the altitude also. And 3 is not enough. They at least need 4. Redundancy should be there. And to remove the uncertainty, one more they say, the idea is very simple. To make it into a technology is very, very difficult. I show you the animation, you will see. Every time You think your phone is just working like that? No. So many people have worked so many hours to make the technology simple. I'll show you this animation you see here. Correct? So, because the satellites are low Earth, they are visible only for 6 or 7 minutes. The switching of the satellite also has to happen. Correct? So everything is happening, but you don't see that that is why the chip is important. The IRNSS has come, but the chip has been done, and everybody has to implement and then test it out. GPS has done it. Other systems have done it. So this is what is calibration is important. Timing is important. If you make an error in the time, you will be off by so many kilometers. Okay, so idea is simple, but technology very sophisticated. We have mastered it actually. Okay, then you have all small satellites, big satellites. I will not touch this. I don't have time. You can have separate session on this. How do you control? What are the perturbations? All that. Orbit dynamics. How do you estimate orbit? How do you estimate attitude? How do you move the satellites around? All these are important. Let me not go. I will touch the launch vehicle. The time is already up. I will touch the launch vehicle briefly and get into SLV3. Okay. Basic principle. Third law of Newton. Balloon, right? How do they exhaust? You burn a lot of fuel and exhaust through a nozzle. The reaction will lift it up. You can work with a simple balloon, and that's it. That's a principle. Okay. Now you see here. Normally, if you walk 10 kilometers per hour, horse riding is 20, car is 100 kilometers per hour, aeroplane maybe 1000, rocket is 30,000 kilometers per hour. That much energy you have to develop and give. I showed the picture earlier, right? That is why that is most difficult one. Okay, some history here. Tipu Sultan had rockets in 1700, used for fighting. I took it from some museum. Okay, so it was used. It is not new, but after that we left it. Okay, now I will talk about SLV3. Is that okay, sir? In another 5-10 minutes I will finish. Is that okay? Hello? Hello? Sir?
Yes, sir.
Yes, sir. Absolutely,
Yes,
sir.
sir. Yes, yes.
Yeah, nobody is answering, so I thought my line went out.
Sorry, sir. Sorry, sir. You can continue, sir.
Okay. I'll finish it. Okay, about SLV3, that I worked very closely with Kalam and my team. It is see, at that time, nothing was there. You remember, this is around 69. ISRO was established and TELS was set up. And the project was initially started at 73, SLV project. See, we are all young and we have studied only. We have not seen it. We have no expertise outside. All that. That is a scenario. Okay. The mission was very simple. They didn't put the strict specification. Put a 40 kg satellite into near Earth orbit. And at least it should stay there in the orbit for 100 days. That's all. What is the variation? 400 kilometers, is it plus 10, minus 10? Nothing. So desired orbit circular 400, it can be 200, 900. If the lifetime is 100 days, that's fine. Remember that. That's why the mission specification were very loose. Our objective is put a satellite into orbit. And it should not come within 10 days. Come back to Earth. That's good. Huh? So, yeah, did not have any closed loop guidance and all that thing. Develop the capability for the country from scratch. Very important. We didn't know whether we can do it or not. No propellant was there, no structure was there, no motor case was there, no pressure vessel was there, nothing. Everything from scratch. Okay? No external collaboration at all. Purely it was a make in India. Now you are talking about Atmanirbhar and all, right? SLV3 is a Atmanirbhar in 70s. I know it. I can tell. Okay? Then with Kalam in 73, first flight in 79 was a failure. 69 ISRO's birth. Within 10 years, we tried. That great achievement. Failure. What was the problem? A silly problem. During a checkout, one control valve opened in second stage, but did not close. We watched it also in the TV. We watched, but we didn't realize it. This is what I'm saying. Failure is the learning. Failure is the Kalam's quote again. Your best teacher is the first mistake you make. Yeah. Flight went into Bay of Bengal, and when we returned, Trivandrum, people used to throw stones at our VSSC buses. It happened. I'm not joking. Check with anybody. And people called SLV as a sea-loving vehicle. Yeah. Okay. But second SLV in 1980 was a success. Rohini was put into orbit. Okay. Okay. This is the first SLV. You can see the person. The first one is Kalam. This one. This is Professor Dhawan, chairman. This is Srinivasan. The person behind is Sandless is not anymore. Srinivasan also not more. Dhawan also not there. Kalam also not there. And this is Pant, Shar director. He is also not there. These are all the Bhishma Pitamahas of our rocket systems. PSLV is his brainchild, Srinivasan. Okay, how the rocket goes up and all, I have shown it. But I will show you animation of that. You can see it here. It was very difficult. Yeah? This is the launch pad. The red line is the orbit. You can see that it is taking off. It's not exactly from sharp, but you can get the idea. Second stage is burning. And after that, it has to be separated out. The top one is the heat shield. And after some time, when it is nearing the orbital condition, we call that point as injection. When it comes very close to that, the heat shield will open up and the satellite will be put into orbit. So that condition is the injection condition. We have to precisely deliver at the correct altitude, correct velocity, so it stays in the orbit. So this is a one-time affair. If something fails, you can't control it. Okay? This was done actually. Okay. So let me close. SLV-3 successfully launched and a couple of flights happened after that. And then they went further. SLV was the beginning. 80 to the present time, road we have come through. SLV-3, ASLV, PSLV, GSLV, and then GSLV Mark III and all. Bigger and better and heavier. Okay. I'll leave it. This I want to talk and close about the team. Okay. If some of you can recognize, you can recognize. This is Majid. He is in charge of all the separation system, pyro and all. This is Kalam. The next one is Shashikumar. He is in charge of all the motor case fabrication, all mechanical thing. And this is me, next one. And the next one is the Dev. He is in charge of mechanical integration. See, this is a team. I mean, not all are here, but you can see this is PS Nair. PS Nair is the administrative in charge. All logistics, all problems, we will go to him. And this person behind is Nambudri, expert in solid propulsion. And of course, you can see this fellow. I don't know whether you recognize. He is nothing but no other than Sivadana Pillai, Brahmos. We are all the team. Not all the people are here. We used to have discussions. This is the bigger team. I don't want to spend time. You can see those of you, Madan Nair is here. You can see Madan Nair is here. This is Dr. Gupta. He is no more. Vedachalam. All these people are still there. Some of them are there. Some of them are departed. But this is Mr. Kuru, propellant in charge, Gavarikar. Propellant, solid propellant. Okay. So these are the team. Let me close it. We were very young. When others said it was impossible, all the fellows were saying that this fellow, what rocket, they are not launching anything, they will put satellite. We never bothered. We worked harder. You know where it came? From the boss. Of course, Kalam. Okay? The more others said it is not possible, we worked more harder. Okay? Team was led by Kalam, PD, Srinivasan as DPD. Both they will not take they will not take no for an answer. If you work with them, that's what Varun was saying. How do I find your picture? You go and find out. They will take no as an answer. Okay, team was young and we grew with ISRO. We never bothered whether we can do or not. Everybody was skeptical. We said we will work hard and that's it. It will work. Conclusion, we had regular project review meetings. Others can say that it starts at 2:30 and going up to 10. But Kuna, everyone falling due to exhaustion. And in this meeting, no holds barred. There are a number of occasions I have told Dr. Kalam itself, what you are doing is nonsense, foolish. No, nothing, free for all, technical points. Yeah, no hold barred. Evaluate the problem and find the right solutions. It was learning experience for the country and run an interdisciplinary technology project by ourselves for the country. That's why ISRO's foundation were set at Aryabhatta, Bhaskara. We were working at similar times and in SLV3 at that time. So satellite technology, network technology, launchpad technology, rocket technology. Rocket technology means 20 different disciplines, everything from scratch in 10-year period time. The foundation was laid. Okay, this is the current event. I will not go through that. You can see how it is evolved. Okay, solid propulsion, liquid, cryo, everything has come. Everything. I was also an advanced technology planning officer in Bangalore, ISRO headquarters. I used to run with Rangan simulation for Mars in computer. Then people used to make fun of us. This fellow has not launched a satellite. They are saying Mars and all. Whatever we are dreaming, whatever we are saying at that time, in 10 years' time, it has been realized. We reached Moon. We reached Mars. Everything is possible. That's the point of Kalam. Dream big. Try it. You will achieve it. So my close here. Summary. I just give a brief overview. I have not touched major areas, but you get an idea. This is only the tip of the iceberg here. And still, we need more adventurous minds to explore last frontier. Space is called the last frontier. Every new things can happen here. So that is the limit. And I will close here and open up for discussion. Thank you. And any question and answer, you can take over and then start. Okay. I hope you have suffered with me for 1.5 hours now.
And not at all, sir. It was a beautiful experience for us.
Okay.
Thank you so much, Sundararajan, sir, for being with us today and giving a beautiful presentation. In fact, I never thought you'd be covering such a vast topic in the short time span that you were given.
Remember, I am a professor. Yeah.
Yes, sir. That is the reason, I think. Obvious. So, Kuti sir, can you please, should we move to the panelists or should we go to the Q&A session?
Panelists will be. Yeah.
Excuse me, Kuti sir.
Varun, sorry, Bharat.
Yes, sir.
Our normal format is after the talk, panelists will be invited. So let the panelists have their say. Then there will be question answer soon after that. They may take 5 or whatever time, 5 minutes or so, or whatever time they want. PJ Bhatt, and then our Abhinand. Then we'll move on to the question answer. Is it okay, Dr. Sundararajan?
I love to hear from PJ Bhatt. We have together 24 hours in Star. I'm seeing him after a long time, but
actually, Dr. Sundararajan is longing to hear you, Bhatt, and he told me yesterday your IoT kind of experiences, etc., which they had in the beginning itself. So,
me too. I'm just waiting.
Okay.
Bhatt, floor is yours.
Yeah. First of all, namaste, Dr. Sundararajan sir. Such a long time. It is almost 40 years.
Yeah. I remember the oats days. Yeah.
Yeah. I remember oats. Anyway, for the benefit of others, I just want to, because I want to spend 1 minute, 1 or 2 minutes on Dr. Sundararajan sir, my interaction. It was way back during Bhaskara Apple time, when I used to be a very junior programmer, and we used to write software for satellite health control. And I was working on TDC 316 computer, I remember very well. And all our software used to be evaluated by a team called OATSG, Orbit Attitude Trajectory Software Group. And Dr. Sundararajan sir was a member of it, along with Dr. Prabhu, Dr. Narayanan, Dr. Ramani, Dr. Vishwanathan. So it's great stalwarts. We all have come up with the ISRO thanks to these great people. And those days, it was, for us, we used to make our software ready, and they used to come and check the software, test it out, and give us very valuable comments. Anyway, I leave it at that. I can talk much more on that. But it's such a nice thing. I feel it is my honor for me to sit as a panelist in this talk by Dr. Sundararajan. In fact, sir, it was such a highly motivating talk for youngsters, especially because I do go around and give a lot of talks in various schools, colleges, and all. My passion it is. But today, after hearing your talk, I got so many points, which I will include in my attempts. So it was an excellent talk, and especially you took on right from history, right from starting from Sputnik, and going through the etiquettes of orbital dynamics, touching all of them, and how building up a base for talking of what is satellite mission, rocket mission, and then how from applications point of view, you derive in such a small, brief way you conveyed how you define a mission, go about analyzing it, building it to design, and then realizing it, and then achieving it, finally carrying out the mission operations. You touched upon so many aspects about various kinds of satellite missions, touching almost all aspects of satellite mission applications. And then you dealt with so much, all these aspects. One more aspect I liked very much, sir, is the way you made it so interactive. It was, in fact, all the webinars I have been attending of UL Space Club, I don't think this much interactive session happened any time. That is my feeling. It was such an interactive session, and I am sure all students have enjoyed it. It was such a fantastic experience for me. And more than that, there is another aspect of the whole thing that I feel happy about today, to sit with Mr. P.S. Abhinand, our young friend who has achieved so much. And I have been in touch with Sir, Dr. Sundararajan sir, for your information. I am in touch with all the youngsters for quite a long time. Okay. So because of that, I feel very honored.
But you are doing a good service. You are doing very good service. Please continue that. Yeah. Involve me also. I will come.
Yeah, you are welcome, sir. Your blessings. So, in fact, I am sure our youngster friends would have had a lot of questions. So I think I will leave it at this, and then let us listen to my other panelist, Mr. P.S. Abhinand, and then afterwards let us go to the question answer sessions. Okay. Thank you so much.
Hi, good afternoon to all. And this is a honor to just like jump between two legends in the Indian space technology. This is the second time I'm enjoying a talk from an SLV team member. First time I think Vedajalam sir came in Vadagara to give a talk about propulsion systems and cryogenic systems. And whenever I'm in a class like this or a webinar like this with a SLV3 team member or a person who built with this Indian space program, first thing I notice is that he is enjoying the talk more than us, because they are going through the histories and their experiences, and it's a very, very wonderful experience to see the enjoyment and the happiness in their face than our face. And this talk covered almost every aspect of the space technology, and we are thankful to them, to you, sir, because without you and the team of you, we can't explore the space, because most of the people, those who are interested in theoretical sciences or pure sciences, are there in this group. But without all these technologies, you can't go to space, you can't explore it, you can't find anything. So this is a very, very fundamental as well as a very much motivating talk we got, because every time we get a talk, we get so many information. But beyond that, we get so much motivation and your experiences. It's very wonderful because a man working with Kalam and everybody in this group have a very passion about know about Kalam and his activities. And a man who is closely worked with Kalam, that's a very we are enlightened with your presence and your talks, sir. Thank you for everything. Thank you, sir.
Thank you so much, Abhinandatta. In fact, we are really motivated by students like you, and not just by the veterans that we've been speaking with for the past few weeks, but to be able to interact with students like you is also a big motivation for us. Now, there you can see my face, right? Excuse me?
Yes, yes.
Yes, yes.
Okay, sir. So I think it is time for the long-awaited question and answer session. Well, we receive a whole lot of questions every webinar, and today also there is no shortage of questions. So it is a very difficult job for me. I have to look at the chat box and then select the questions in the minimum time that I am provided. So let's begin with the questions. Now, the first thing that I want to tell the students is that when you come to ask the questions, do try to switch on your cameras. And before you ask the questions, please do introduce yourself, because most of the names that is provided in Google Meet is maybe your parents or your siblings or something. So when you ask the questions, please do introduce yourself first. So the first question is a very general question. It is a doubt that a lot of people have about whether there will be collisions between satellites. But in fact, there are even organizations internationally which make sure that that doesn't happen. So the question is from Vishnu K. Nambiar. Can you please come forward and ask your question? But before that, please do introduce yourself. Vishnu K. Nambiar? Is he online? Let me have a check. Vishnu K. Nambiar, I see that you're online. Please switch on your mic and your camera. Excuse me, hello? Vishnu K. Nambiar, can you please come forward? Okay.
There may be some technical problem.
Okay, maybe that is a problem. So we can switch over to the next. Oh, sorry. I think I can narrate it.
You ask the question.
Yes, sir. So the question is there any possibility for collision between two artificial satellites, since there are many satellites orbiting Earth? Are the satellites developed with capability of avoiding collisions? And there has been another question or a remark from somebody that there are international organizations that prevent that as well. And there has been another question from someone else asking, do satellites have any sort of mechanism inbuilt which helps them autonomously or manually avoid such collisions? Can you please elaborate?
Okay. My knowledge I will answer, but can answer far better. Certain orbits are very crowded. Geostationary orbit is highly crowded. Yeah. So even in low Earth orbits, earlier this was not a problem, but now because a lot of countries, a lot of people are putting satellites, there is a collision risk. So what the best way they avoid is they monitor this, and if there is going to be a risk of collision with another satellite, the similar orbit or same orbit, they delay the launch. Launch window is selected to avoid that. But as far as within the satellite, whether any autonomous system has come, not yet. That's what I feel. But if it comes, it can go up or go down and do it, like collision avoidance in aircraft. They should be building that in the satellite. I don't know. That's not difficult. It is possible. Yeah. But can you amplify? Yeah.
So may I add, sir? May I add something?
Absolutely, sir.
In addition to what Dr. Sundararajan has told, generally, you know that all the objects in the orbit, including working satellite, non-working satellite, above certain size, are all tracked, and they are given some numbers, and their orbit is made available through some mission. Let us not go into the details that you get elements from an organization called NORAD, 2-line elements. With this, generally, a calculation can be done with respect to the trajectory of working, non-working satellites, their path and all that. And sometimes, if the satellite doesn't have automatic provision, generally, we carry out what is called a collision avoidance maneuver. In the sense, if there is a possibility of other object coming within certain distance, we slightly change the orbit of the working satellite to avoid this collision. This is also being done. This is also being done in addition to what Dr. Sundararajan told about delaying the launch with respect to the initial orbit itself. That is what I just wanted to add that.
Okay.
Thank you, Bhatt. So the next question is from the person whom we call Question Bank, because he posts a whole lot of questions every webinar. He's possibly one of the two most active members of UL Space Club who are very much into asking questions. And he's Abhiram TP. Well, as I said, he has asked a whole lot of questions. So Abhiram, please do stick to your first question right now, Abhiram. Abhiram?
Okay, thank you, Varadaka. Okay.
Yes,
Good afternoon, sir. I'm Abhiram TP, a junior member of UL Space Club. First of all, thank you, Sundararajan sir, for your interactive session. This session is really informative. Thank you, sir. Can I ask my first question or all questions?
Yeah, you ask.
Abhiram, you can stick with your first question now.
Okay. Sir, can you describe about thrusters?
Which one?
Thrusters.
Yeah. What do you? Okay.
Excuse me, sir, can you please cover reaction wheels as well right now when you answer this question?
But is the right person. He's talking about satellite thrusters and reaction wheels. Yeah.
Okay.
Yeah.
Sir, you can continue, sir. You can.
No. Okay. Satellite. Okay. See, this is what this comes in attitude control of satellites. See, you had to maintain the orientation, right? So there are a lot of disturbance acting, like ablateness of Earth, solar perturbation pressure, a lot of disturbance, right, acting on that. It will make it oscillate, or worst case, it will make it tumble. You have to bring it back to normal orientation. Control systems are used, and some of the control mechanisms are, you can use reaction jets. That is what normally used. So you control what do you call is every body's dynamics is governed by 3 attitude motion: pitch, yaw, roll. So you can have reaction jets to control the motion or the pitch, yaw, roll. Reaction jets are provided, and they will fire for short duration in pulses and correct the motion. That's one. Another is through reaction wheels and momentum wheels, because in space, right, the momentum has to be constant. So they work on that mode to correct that. So these are all part of the control system: reaction wheel, momentum wheel, reaction jets. So this is all set up with the control logic, and depending on the error, appropriate devices will come and activate that and set it back to normal condition. Yeah.
Okay, sir. But sir, do you have anything to add?
No, it's whatever is required, Dr. Sundararajan has already told. Okay.
Okay, sir. So Abhiram, you can continue with your next question. Abhiram?
Okay. Sir, is there any possibility for reignition of solid booster rockets? Any solid
booster rocket? Hello. Solid means once you fire, that's it, gone. You can't come back. Liquid is the only thing we can do it. Cryo, you can do it. Because liquid is like a tap. You can turn it on, turn it off. Solid and all, how do you turn it off and turn? See, if there is a fire, can you stop the fire and restart again at your control? Actually, solid boosters in uncontrolled combustion, you do it in a pressure vessel so that the pressure is within the limits. There is no control. Once you ignite solid, that's it. Can you stop the patas? When you ignite, can you stop? It's all pyro, right?
Pardon?
Pyros are like that. Explosion. Yeah.
Okay, sir. Now, speaking of solid and liquid fuel, there has been a question from Han Joseph regarding that. Han, can you please come forward?
Okay.
Han
Sir,
Joseph?
my name is Han Joseph. Hello?
Yeah.
Is it
Go
clear?
ahead.
Okay.
Yeah,
My
yeah.
name is Haman Joseph, and I'm studying in 10th standard. My question is, what are the pros and cons of solid and liquid propulsions?
I thought this is a quiz question, right? Varun? Is it a quiz question? Can I reveal the answer?
Sir,
hello?
Pros and cons
Yeah,
of
yeah.
solid.
I want to check with him whether I can give the
Yes,
answer.
sir, your question also there, and we just made few questions from your description. So please about that.
No. Can I give the answer? Okay, I'll tell you. I'll give the answer anyhow. Just fine. So, solid, low energy propellant. Normally the propellant or the characteristic of a propellant is defined by the specific impulse. Actually, we call it ISP. ISP is the indication of the energy content the propellant can give. I'll give you the number.
10.
Huh? Yeah. Solid normally around 250 seconds. Liquid around 310 seconds. Cryo is around 410 seconds. So, with a smaller propellant size, you can achieve the velocity with cryo. The next level is liquid. The great advantage of liquid is you can control. Cryo also you can control. Then why don't you use everywhere cryo? Cryo is difficult to handle. System design is very difficult. Liquid is somewhat better. Solid is only 250. Once you ignite, that's it. You don't have any control. So that is why solids are always used in the booster. One shot firing and that's it. Throw it away. Liquid, you can restart. You can switch it off, restart, and do reignite. All that is control is in your hands, depending on that. For satellite control, that's why they have used liquid reaction jets. Anytime they can fire. They raise the orbit and all, right? They fire number of times. Liquid is the flexibility in control. And at the same time, 310. Why they don't prefer cryo and all is cryo is very complicated. Handling and all, you don't need it. You need it for a rocket to get the right velocity at the end. Cryo is used. They don't use cryo reaction jets. No. They normally use hydrazine or UDMH and N2O4. These are the liquid propellants. Whereas essentially the control for satellite with jets is called reaction jets. Does it answer your question?
Yes, sir. Thank you, sir.
Or it confused more? Okay.
Okay, sir. So speaking about reusability, can you please comment on the technologies that SpaceX now possess?
Yeah. SpaceX is great technology, because right now what we do is we launch from shore, right? The boosters are falling in the sea. One of the easiest ways to bring it back with a ship and all, tug, bring it back and refurbish doing. We are working on that reusable. But what SpaceX has done is they have designed the system such that after its use, it flies back like an airplane and comes and lands at the launch pad. Correct? That's great. If you go somewhere else, what is the problem? And every time they were using, right? So this, they made it possible. And not only that, it came back and landed vertically with a perfect landing and landed near the launch pad. That way, so the same rocket can be used again and again. The cost comes down. So this is the problem with the boosters in our system is it's only one-shot affair. Once you used it, you don't bring it back. If you can bring, space shuttle was like that, right? So they got the boosters and then shuttle came back. They assembled it and used it. But they had a shuttle separate. But this is the same rocket which lifted satellite. The booster part, it came back.
Okay, sir. Thank you so much for answering that.
Technology has developed a lot also for that.
Yes, sir. Is there any effort from any other organization, especially government organizations like ISRO, into developing such technologies other than SpaceX?
No, we were working on reusable vehicle, but that technology, I don't know whether they're working now or not. I left ISRO 15 years back. So, but now at that time we had a reusable launch vehicle, They did a flight test also, the capsule. What we do is, normally we monitor where it falls in the Bay of Bengal. And the ships are positioned near that. They go and attach the booster motor case. They bring it to shore. And once it is, you look at it, the damage in that and repair it and fill it up with insulation and all, use it again. That has not happened yet.
No, so how many times can SpaceX actually reuse it? Is there any?
That depends on the design of the motor case. Design of the motor case. Solid is somewhat difficult, right? It gets affected more. This is liquid. Liquid, you can use it again and again, except that, and that's why it is not falling on the sea. Because if it falls on the sea, the impact itself will damage it. So they are bringing back as like an airplane. So the reusability is, they would have designed for 5 times reuse or 8 times, something like that, and build a factor of safety in the motor design.
Okay, sir.
Sir, may I add something?
Yeah, please.
Yes, sir.
Especially about the reusable launch vehicle progress in ISRO afterwards. There has been a project called RLBTD, Reusable Launch Vehicle Technology Demonstration. And in 2017, if I'm not wrong, 2017 or 2016, one test flight took place in which the upper stage suborbital flight test was conducted. Suborbital flight. Suborbital, for the benefit of students, I'm telling, sir was showing one diagram earlier, where trajectory was going and coming back, hitting. The one more name which can be given for that is suborbital flight, like ICBM, he was telling ICRM, ICBM, so that kind of a thing. So suborbital flight test was conducted. In the same test, they used the capsule, our human space mission. There is a crew module prototype. They used for the purpose of re-entry, atmospheric re-entry test also. That has happened, and this TSTO, what we call it, a two-stage to orbit, this project is on. Of course, you are right. It has gone on slightly slow, but progress is happening. PSSC is working on that. Thank you.
Great to hear that, sir. So the next question is from question bank number 2, and that is Febin Firshad. He has also asked plenty of questions. So let's stick with the first question, Febin.
Hello, is it audible?
Yeah. Go ahead.
Absolutely. Continue.
Okay, first of all, I thank UL Space Club and all the coordinators of this webinar. And hearty thanks to Sundararajan sir for taking such an informative webinar for us.
Okay.
My first question comes on orbits. Sir, can you explain about Molniya orbit and Molniya launch vehicles of Russia, the first intercontinental ballistic missile?
Okay. I don't know about the ISRO itself now. You are asking Russia. Okay, I will make a guess. I can tell you one thing. When Russia launches from their launch pad, that's what I said, that inclination is very important. Right? Inclination, because they are near northern latitudes, near poles. So they cannot launch in equatorial and all. Very difficult for them. So they launch with, we launch from shore around 45 degrees inclination. From there is higher. It's not 90. They can easily do 90, but the inclination is very high. So the problem is, for them to put into geostationary orbit is difficult. That's why they prefer geosynchronous orbit. And instead of having 24-hour visibility, if you have 23 hours, it's okay. They can put 3 satellites to manage the time coverage. And that is how they do that. So, but very important from the beginning, Russian technology has been really brute force. You saw the booster, right? So it is not very highly sophisticated technology. I don't know now, earlier time. So they don't care whether you have enough energy, you can get into orbit, and with inclination, they operate that. Communication satellites, even navigation satellites, they have a system, right? All that, that's what they are doing. But other than that, I don't know about that. See, when you develop a good rocket, space technology, it has a dual use. I will leave it at that.
Dr. Sundararajan, sir, I'm Sundaramurthy. I would like to add some in this for this Molniya orbit.
Okay, okay.
If I'm permitted, this I can answer to this question.
Yeah, you are permitted always.
Sundaramurthy. Okay, please go ahead.
See, one thing what I wanted to tell you is in the geostationary orbit, when you put a satellite, though they are telling that 3 such satellites put 120 degrees apart along the equatorial orbit, it covers the entire world. But that is not right, because of our Earth is almost a spherical shape. So what is happening, when the satellite is in the equatorial orbit, the latitude maximum it can cover is only 70 degrees. Up to 70 degrees only the satellite coverage will be there. Beyond 70, either in the northern region or the southern region, you will not have the coverage from the geostationary satellites. So, but Russian, some of those land masses are there beyond 70 degrees. So that is the main reason to have the constant communications. What they have designed an orbit, which is that 12 hours orbit, where the apsidal line, what we call it as perigee and apogee line joining, is called that apsidal line. When you put that satellite into 63-degree inclination, it is called a stationary orbit. That is, that orbit will not recess. So when the satellite passes through the perigee, it goes very fast. That is, the speed is very fast. Your second law of Kepler. So when it moves around apogee, the visibility time is increased. So by this 12-hour orbit of that 42,000 kilometer apogee, it has 8 hours of visibility. So with the 3 such satellites in that Molniya orbit, if they launch, they have the satellite in turn, 3 satellites take 8 hours each, so that it is equivalent of communication satellite they have 24/7. That is how this Molniya orbit has been designed. It is used only by Russians because they have the landmass which are beyond 70 degrees latitude. I think this, I can add what Dr. Sundararajan sir told, because I'm again a student of Dr. Sundararajan as well as PJ Bhattandal, because still I recall my vivid memories in 1978, 79, 80, we first established our control center for our Apple spacecraft in Sriharikota, and the software packages to control. I think these are all the people who were tirelessly worked along with Dr. Viswanathan, our Ramachandran, and then Viswanathan, as well as our Narayanan Sap, all these people, Dr. Prabhu. These are all the people. But at the time, I was just a fresher, but I was enjoying the company of all these people. Yeah, please.
Thank you so much, Sundara Murthy sir. In fact, thank you for reflecting upon your vivid memories as well. I think PJ Bhatt sir obviously usually covers this topic, the Molniya orbit, during his talks. I've had the opportunity to walk 2-3 talks of him where he has pretty much covered what Molniya orbit is. So next question is also from Febin. You can ask your second question, Febin.
Okay. Sir, my second question is about weather satellites. What are the uses of UHF antennas and dual magnetometers in the weather satellites?
I think Bhatt can answer that question. I think Bhatt is the best person. See, because I never worked on satellite mission directly. I was in the review team only. But really, how they do that and all, the satellite people is Sundaramurthy, but they can answer better. Yeah.
I would request Sundarmurthy because this is beyond me.
Okay, what is happening? This UHF in olden days we were using. It is that ultra high frequency because at that time the antenna tracking technologies have in the nascent phase. So we were using UHF antennas and all. But later on, I think what is happening, mainly the problem is that the link availability becomes a problem. So that's why we have moved on to higher bands like S band, C band, then L band and KU and Ka. So that is how this. Whereas magnetometers, what we are using it for the attitude control. What your earlier question somebody was asking, what thrusters? In olden days, why even nowadays, some of our satellites, we still use the magnetometer to assess the attitude of the spacecraft. And to some extent, we use that magnetic forces to correct the attitude. That's how these magnetometers are being used. And it is nothing but a passing of the current in a coil, so that by controlling the current and the flow direction, we can derive the thrust, the torque, and in turn, we can control the attitude of the spacecraft.
Thank you, Sundaramurthy sir. In fact, there was something that I forgot to. But sir, I think your mic is muted, but sir.
Bharat, if you don't mind, I want to intervene.
It is my pleasure to invite you.
Point on what Sundarmurthy has told about the magnetometer. I want to intervene and ask question to our youngster friends. Can we use these magnetometer-based systems for a satellite which is orbiting around Mars? And the student.
No.
No. Students. For students.
No, sir, no.
No. But my question is same thing. How does a magnetometer work in the Earth orbit?
Yeah. No. I wanted to ask students. Okay.
Yeah. Correct. Let them answer.
Yeah.
Okay. Should I take the honor of answering that, or should I pass it?
No. If you know the answer, you tell. It's okay.
But sir, I think maybe it is because of the magnetic field of the Earth itself.
Yeah.
Yeah, but how?
Yeah.
See, it is vague, right? You have to be clear.
Yes. Yes, sir. My knowledge is vague, sir.
Okay. Anybody else want to try?
Yes, maybe we can go with.
No, I tell my students, if you give me a wrong answer, I am very happy. If you give me a right answer, I am not happy. You know why? If you give me a wrong answer, you are telling me you don't know the subject. I can teach you. If you give me a right answer, what is there for me to talk? Keep quiet. Don't worry. Tell whatever you think is tell.
I think, sir, we can pass it to Abhinand.
Yeah.
He hasn't been into this session right now. Abhinand, that time?
Okay. Can you hear me?
Yeah.
According to my knowledge, that magnetometer is a device that is working with the magnetism for using the strength and direction of the magnetic field. So Earth have a magnetic field because it's have a liquefied core, and Mars didn't have a magnetic field. So when you are working with satellites which is orbiting Earth, it can work with magnetic field of Earth, but the magnet, according to our now knowledge, Mars have no strong magnetic field. So when you are putting a satellite, you can't use magnetometer.
Okay, that looks to be right answer anyway.
But we don't know whether Mars has magnetism or not.
But even if it have a magnetic field, it
Mars
can be very.
No. Certain regions it may have something. I don't know.
Mars doesn't have the magnetic.
Yeah.
See, I think to announce I think our Batsar's question, I can say it is Earth magnetic field to the extent it is a low Earth orbit we can make use. It is mainly what is happening, the interaction of the passage of the electrical current and the magnetic field, that a cross field gives you a cross force. That force is used as a torque. So when the satellite is beyond 1,000-kilometer altitude, also it will not be more effective. That's all, even with our Earth orbiting satellites. So, as Dr. Sundararajan sir put, Mars, we have to unambiguously say that, of course, they say still there is some magnetic fields are available, but we cannot rather quantify what it is, how much it is available, so that we can make use of it for our attitude control.
Thank you, sir. So, well, I think let's move on to the next question then. Well, there has been a few questions asking about hybrid rocket engines. Sir, can you please talk about that?
Yeah. See, normally I can talk. There experiments are going on, even in solid. See, rocket clears atmosphere, right? So it's not air breathing. So the oxygen it needs for burning has to be carried together. So that is why the propellants always, the propellant is there, oxidizer is there. UDMH N24, oxidizer has to be provided. Now, if you can operate in atmosphere like aircraft engines, air breathing engines, you have solid and also use the atmospheric air for combustion. That is the hybrid rocket. So it will work only in the atmospheric region. So if you go still into technology, ramjet, supersonic, hypersonic ramjet, all these are all possible of engines operating in atmosphere. Similarly, they are doing experiments. I don't know what happened. Solid, they don't provide the oxygen separately. They use the atmospheric air and solid propellant experiment. But I don't know to. Definitely, it can't work for satellites because it's in a thermovac condition, no atmosphere. It can work for boosters. So that is the thing they're trying, but nothing big size have come. I'm not in the current technology area, but I know even in VSSC, some people were working on a prototype, putting solid propellant and using air, atmospheric air for it. I don't know how far it has progressed. Yeah, that's for the future. Yeah.
Okay, sir. So Abhiram has asked another question, like how can we absorb hydrogen from space and convert it into fuel, like cryo fuel? Well, maybe for more of like some, interplanetary kind of missions, can you store it and use it?
There are some efforts. I studied somewhere, some moon sand and all. They are trying to make out of that some propellants and all. So hydrogen is okay, but I don't know whether. See, I'm not in touch. See, that is a problem. Yeah.
Okay, sir. So
if I give you an answer, it is wrong. Then you will all blame me. So think not to give the wrong answer. Efforts are there. Idea is correct. See, if you go to that's why they are saying for traveling to Mars and other planets, Moon as a base. You first go to Moon and generate whatever you need for further going is from the Moon itself. Yeah. Yesterday or last week, 3 days back, I read they built a brick with moon sand, right? With urea, and ISRO has built bricks with moon sand and urea. So urea is nice way of chemical. Essentially, it is urine. See, recyclable, reusable, and use that to go further. That will be the idea. Yeah.
Yes, sir. I think Sundaramurthy, sir, can you add anything on that?
Okay. See, yes, of course. Near Salem, they found out the mass, land mass equivalent of Mars. Of the moon surfaces. So I think yes, some experiments are all going on our Ahmedabad as well as our Challakere facility, which is close by the Bangalore. I think some things are coming out, but I don't want to go more into that details because things are not in public domain. I don't want to share. That's all. Though I know some things, but because it is not in the public domain, I don't want to come out. Sorry.
Okay, sir. In fact, let me please remind those other veterans who are not panelists today that this forum is open for all of you. All of you can come in. You don't have to ask, permission like what Sundaramurthy sir said. Can you please permit me to comment on that? You don't have to ask permissions. You can come forward and say your ideas as well. This forum is open to all of you. Is there any other person who wants to come in? Please do come forward. So we can move on to the next question. That is from Aditya. Okay, Sundaramurthy sir.
No, Bharat, it is not that. Better everywhere you have to have some discipline to be followed.
Yes, sir.
That's the reason. Yeah.
But maybe then you could ask permission and I will permit. Now, who would expect a student to give permission to ISRO?
Bharat, the question about Mars, I think Mars is full of methane, right?
Yes, sir.
That is why the question, whether you can generate hydrogen from methane and use it as a propellant. Hydrogen as a propellant is very difficult to handle, even in ground.
No, sir, why don't we use methane as it is? Why don't we just use methane as it is?
The other question is whether methane can be used as a propellant. That's a good question.
Because methane react with oxygen and it's an exothermic reaction.
Yeah.
Okay, so let's move on to the next question. That is from Adidev JD. He has commented a lot during Sundararajan sir's session. So Adidev, can you please ask your question? I think the question was about the difference between some kind of humanoid robots. Adidev, can you please ask your question?
Am I audible?
Yes,
yeah.
Absolutely.
My question is, what is the difference between Robonaut 2, the humanoid robot, which is used in STS-133 mission, and the Vyomitra, the Indian Gaganyaan mission humanoid robot?
I see the humanoid robot and all. See, some of the operations they want to do with robot in space. Okay. So if you have a humanoid robot, maybe they have built intelligence into that, some level, not the full level. Some decisions they can analyze and take corrective action, whereas the other robot is just a mechanical. You ask it to command it to do something, it will do it. That's it. So this one more autonomous system. Normal robot doesn't think. If you build autonomous system into that, so that depending on the condition, it can take a corrective action or change its strategy appropriately. That will be more like humanoid, more like a pilot kind of thing. So that is what they have done it. What ISRO is doing, I am not sure because I'm not in touch. Yeah. What Sundaramurthy said is correct. I don't know, so I'm not telling. He says this is off the record, so that's different. Yeah.
Okay, sir. So I think
a routine task they can give it to a robot.
Okay, sir. I think, thank you, sir. So the time is almost up. So let's end with this last question. If there is any other question that anybody has to ask, please do tell us in the comment box right now, or we can discuss it later in the groups that we have. So the question is from Febin Firshad. Febin, can you please ask your last question, the final question that you've asked? Febin?
Okay. The last question was about ADIOS satellite of JAXA. Sir, is there any particular ADIOS satellite?
No, I'm not familiar. Go ahead.
Sir, is there any particular reason for sending the first international platform called ADIOS of JAXA to a 830 kilometer sun synchronous orbit? As far as I know, orbits, the sun synchronous satellites are ranged from 600 to 800 kilometers. But this is something called 830 kilometers. Why is so?
No. What was the mission for that satellite?
ADIOS. I don't know. Is there any other name? I only know about ADIOS.
Sir, it is an Earth
Which country?
observation satellite.
Which country?
Japan.
Oh.
It's an Earth observation satellite, sir.
Oh, okay. Okay. I'm not. But can answer if he knows the answer. Yeah.
May I tell? I don't know about this particular satellite, but your statement that there cannot be sun synchronous orbits beyond 800 kilometers is not right, because our IRS-1A,
900.
very first remote sensing satellite, it was in the range of 900.
900. Yeah.
It was in that. So sun synchronous orbits are possible even beyond 900 also. Even sun synchronous orbits are possible. The question is the altitude of the satellite depends on many other factors. You know, one simple thing is higher and higher you go, they were with the camera capability, the resolution.
Yeah, correct.
The resolution suffers. So that is why most of the spy satellites are in the range of 250 to 350 kilometers. So it is not like, but I don't know about this particular. What is the spelling of this particular satellite? Spelling? Can you tell the spelling? Because
okay, sir. It is
ADEDEOS, Advanced Earth Observation Satellite.
Oh, okay. It may be some remote sensing satellite.
Yes, it's used for monitoring global environmental changes.
Is it hyperspectral or something? They may have put advanced remote sensing camera, you know, hyperspectral. Normally they do multispectral, but this may be a hyperspectral. I don't know. Yeah.
I suggest Bharat, I suggest that ask Febin to send this as a mail to me, and I will definitely come back with an answer.
Okay, sir. I'll take care of that, sir. So I think let's end with the final question. It's not a question, it's more of a remark. So obviously the most ambitious project that the whole world is looking at right now is, of course, Starship of SpaceX. So let's end with your comments on the Starship. Can you please tell us the minimum information that we need to know and what you think about it?
Which one?
Starship.
Huh? What is
from SpaceX?
Starship? I'm not familiar. What is that?
Sir, Starship of SpaceX.
Oh, SpaceX, is it?
Yeah,
No. Is it like a science fiction? Star Wars, Star Enterprise. That's what you are asking? Starship?
No, sir. It is actually a real rocket that is almost being built.
No, I'm not familiar. See, this thing is, you find out the answer and let me know.
Beautiful, very nice.
Yeah, you have Google. I'm not familiar with this.
Bharat, do we have any more?
No, sir. Abhiram has asked.
Are we going to close now?
Please allow me to ask a question. Abhiram has asked a question, sir. Can I please invite him?
You are saying that we are closing and last question and all that.
I was saying that, but there has been a request from him. Can I please invite him?
Please go ahead. Please go ahead.
Abhiram?
Okay, am I audible?
Yeah.
Sir, each rocket nozzle have converging section, throat, and diverging section, but jet engines are really different. If we change the structure of jet engine into rocket nozzle, can we get more force?
No. Jet engine cannot be, because see, the combustion happens in high pressure. So the motor chamber is a high pressure vessel. Jet engine doesn't carry that much pressure. So the normal thing is for jet engines is a milder version of rocket propulsion. That's all. Air blending. This burns and put it. They try to make the shape like that, but this one is because the velocity you need, right? Newton's third law. Whatever the jet velocity at the exit nozzle you get, that will be the velocity imparted to the other side. So they operate in very high pressures. The rocket motor case design, fabrication, and testing is under high pressure and temperature. Jet engine is not like that. Jet engine is a milder version of that.
Okay, thank you, sir. Thank you so much.
Yeah.
Thank you so much, sir. That the end of the Q&A session. It was absolutely a beautiful one with not just you, the other panelists, Dr. PJ Bhatt, as well as Abhinandan also coming in, and Sundaramurthy sir dropping a few remarks and answers as well. It has been a beautiful session, and it has been my honor to try and moderate it. Yes, there has been a few mistakes that I've made. Please do pardon me for that. We are moving on to the conclusion, and well, there's no other person to hand it over other than Kuti sir. So Kuti sir, can you please handing over the baton to you?
Thank you, Bharat. Thank you, Bharat. I'm very happy today for 2-3 reasons. One is that the style of our today's webinar itself is something different from what we are used to. For the last 12-13 webinars, we followed a particular way, and in this we found, every webinar is a progressive step for betterment, and this is Dr. Sundararajan has brought a new dimension in the way in which the students are interacted and talked to. So that is very appreciable and very nice, and I'm very thankful to Dr. Sundararajan for that. But one more important thing that he was saying, that we may have a time crunch for doing the whole thing, but somehow his time management has been excellent. And I found him earlier than what I expected. The thing ended in a very nice way, covering everything, and inspiring and motivating. Somebody said almost the same words, and I am only repeating that. Is the way the whole thing started, as if we are sitting in the 1st standard, 8th standard, 10th standard kind of a class. I started recalling that kind of a class, the way it started coming up. So that way, it's a very, and relating everything to the principles and theories of what we learn is something which we don't normally get from this kind of sessions. So that way, it has been a very fantastic one, and with the combination of Dudley, PJ Bhatt, it has added more fuel and fire and everything into the whole thing. And Abhinand is Dr. Sundararajan may not have met him. He's one of the person who is instrumental in bringing the quality of Space Club to this level. And there was a mention to Vedachalam. See, Vedachalam is a person who was not willing to come to Calicut for a space camp program. And we met him in Sriharikota, SDSC. Abhinandu was invited by the chairman to witness a launch, PSLV C-42 launch, and we went there. And in that one fine morning, early morning walk, we happened to meet Narayanamurthy and Vedachalam walking. And in that talk, Vedachalam asked some question to Abhinand on mathematics. See, that, discussion went on. I thought, Abhinand is getting exhausted, but the thing was happening in a different way. At the end of it, Vedachalam told me when we reached the guest house, Kuti, I will come to Calicut whenever you want. That is how he came to Calicut. Instrumental is Abhinand's, interaction with him made him a feeling that the students of Calicut are really worth spending time for. So that we wanted to use the occasion to mention that. So that is a fantastic talk. Time is already getting late, and I saw Hans Joss here. Hans Joseph, you are the person who joined quite recently in our group, isn't it?
Yes, sir.
I am starting seeing you having a lot of discussion in the group, and within such a few days itself, you got one among us and started this kind of thing. I am very happy that the quality and the kind of persons who are coming to our group are adding to its worth. It's a very nice thing. There is another happy thing for me to see, and it's a very nice day. And Shajil Marsh is not there. Normally, he's the man who will be winding up and requesting a lot of thanks to our Damodaran Mash. So may I request our main coordinator, the person who is making things happening, the teacher Damodaran Mash, to come and give a vote of thanks. Damodaran Mash.
Excuse me, sir, can I please add something? Damodaran sir, can you please pardon me? And there was one thing that was to be said before the vote of thanks, and that is the UL Space quiz that is followed by this session. The link will be given in the comment box right now by Varun. You'll have a few questions, and the link will only open once the webinar is closed. So all the students go attempt it, and the winners will get prizes, and they're sponsored by Cinderbe Nurture. That is it. So make use of the information that you got from
an announcement about next webinar also.
Yes, we need to make the announcement of the next webinar. And Kuti sir, can you please take the responsibility? Excuse me, Kuti sir, your mic is muted, Kuti sir. Hello, Kuti sir, your mic is muted, sir. Can you please switch it on? Well, I think
Bharat, you just tell that.
Okay,
You can just
a little bit of a problem with Kuti sir's connectivity, but there is something else that has to be told. The result of the painting competitions that we conducted the previous week, and it is my honor to announce them. So please to wait for the results. So first of all, let's announce the results of the junior category. It was a very good competition. The first prize was for Niranjan K for his beautiful painting. The second prize is for Rohit K. And the third is for Sutlej S. Raj and Kashvi S. Satish. We had a very difficult time trying to judge them and give the position. So since we couldn't make out whom to give the third for, we actually shared it for Sutlej S. Raj and Kashvi S. Satish. Now it's up to the senior category, and the first prize is for Anika BS. That is a very beautiful, wonderful painting. And the second prize is for Lena Najash, and the third prize is for Anand Sriram. So that is from the results of the painting competition. Back to Kuti sir.
Okay, thank you, Bharat. Next Saturday, we are going to have the talk by Mr. C. Radhakrishnan, a famous novelist and a person who is a astrophysics man, worked with in Kodaikanal Observatory, M.K. Vainabapu's place. And his talk is going to be on science tomorrow. Science tomorrow. This is the topic he has chosen. And most probably it will be, proceedings will be in Malayalam. Anyway, that is to be finalized maybe today, tomorrow. We'll put in the poster. He's a person who had a lot of interaction with the public, common man, through his novels. His novels are very famous novels, and in fact, he has been chosen as a person to speak in the webinar by our students only, because they also wanted a kind of a different thing from the novelist angle. But anyway, he has chosen science tomorrow as a topic. So let us see. One important thing is this talk will be not at 3 p.m. It will be in the morning at 10 on Saturday, coming Saturday. Anyway, there will be a poster with all the details that will come. Okay, Bharat. Damodaran Mash.
Okay, thank you, Kuti sir. So let's move to the final proceedings. It is my pleasure to invite our very own Damodaran sir for the vote of thanks.
What's happening, Bharat? Damodaran Mash?
Let me have a check.
It's not there in the list.
Damodaran sir isn't here. I think he has some technical issues as well.
Is it? Oh. Okay, and Shajil Mash also is not there, isn't it? He had to go for he had to go. He had told me he'll go. Okay, then no problem.
We
Then
had to pass it on to the inexperienced myself.
no, we can do one thing. We can invite one of our students to say a word of thanks. Why not?
Can I say something?
Oh, sure. You are more. You are. The floor is yours today. Entire day. Yeah.
No. I want to thank all of you for a nice session. You said about Calicut students. I agree with that 100% because I have interacted with a lot of students in different places. The response I get, see, the teacher doesn't teach students. He also learns from the students. See, students get the material from the teacher, and the teacher also learns from the students the thinking, how they question. So I want to thank all of you for this wonderful session. And I'm Vedachalam, you mentioned, right? Is not coming at all. I'm telling you advance now. I will come anytime you call me, and I want to come as quickly as possible when COVID is over. So I want to see all these guys face to face and interact with them. We will do that sometime. And I will end my thing with one quote. A good teacher is not the one who answers all the students' questions. I will repeat. It is like a doha. A teacher is not the one who answers all the questions of the students. A good teacher is the one who makes the students ask the right questions. So if we can make you ask the right questions, then our job is done. Thank you very much for giving me the opportunity.
Thank you so much, Sundararajan sir. In fact, it was our pleasure to be able to interact with you. So let's end with a word of thanks from Varun. Varun?
Yes, Bharat, thank you for inviting me for lots of thanks. But I don't think that's a good suggestion because I just started the webinar by welcoming all of them, and now we are very happy. So Sundararajan sir, it was a nice talk, and you just helped us also to make a quiz competition, UL Space Club quiz competition for this session of our webinar series. And thank you to Sundararajan sir for coming here and to speak with us. And we are very happy. And but sir, we know that you always attend our webinars. And now, now we know that you are always with us. Your blessings is always with us. And thank you to you, sir. And you answered some of the questions, and we were very happy to have you, sir. And also Abhinand was really active in the discussions throughout the webinar. Abhinand, thank you. And all other eminent scientists, I just think that if I just say one's name and I will miss the other one, it will be not good. So I just want to thank you all eminent scientists who have presented here, and the other members of UL Space Club and UL Space Club webinar family, and also Cosmos WhatsApp group, and a few others are also here, I know. And thanks to all of you. Thanks to all of you to participate in this webinar, and I just invite all of you to the next webinar also. And thank you, Bharat, for handling the question session very good. And thanks to Adil for the technical help for the UL Space Club team. And he's part of the team, and he's one of the brilliant guys of our core team. Thanks to Adil, and thanks to Kuttu sir also. It's not a it's also a formality. I think there's no need to thanks to Kuttu sir because he's a chief patron. But a formal thanks to Kuttu sir, and thanks to all of you. I think thanks to Shejil sir also. Shejil sir, I think he's not present here now. Thanks to Shejil sir for supporting us and being moderating the session and introducing the panelists and the chief speaker to the participants. And thanks to all once more. Thanks to all. Thank you for making it as a successful session. Thank you, guys. Now let's wind up the session. Thank you.
Thank you. Thank you.